Black holes. The very mention of them conjures up images of dark, mysterious voids in space that swallow everything in their path. But what exactly are black holes? Are they really as terrifying as they sound? And, more importantly, could one be closer to us than we think? These are the questions that have intrigued scientists and stargazers alike for decades. In this video, we're going to dive deep into the world of black holes, unraveling their mysteries and uncovering the truths that lie at the heart of these cosmic giants. But before we delve into the details, let's start with the basics. What exactly is a black hole? A black hole is a region in space where the gravitational pull is so strong that nothing, not even light, can escape it. Imagine a place where the laws of physics as we know them break down, where time slows to a crawl, and where the very fabric of space is twisted and distorted. This is what a black hole represents, a point of infinite density known as a singularity, surrounded by an event horizon, which is essentially the point of no return. Anything that crosses this boundary is forever lost to the black hole, unable to escape its immense gravitational grip. But how do these cosmic monsters form? Black holes are typically born from the remnants of massive stars that have exhausted their nuclear fuel. When a star much larger than our sun reaches the end of its life, it undergoes a dramatic explosion known as a supernova. During this explosion, the outer layers of the star are blasted into space, while the core collapses under its own gravity. If the remaining core is sufficiently massive, it continues to collapse until it forms a black hole, a point where gravity becomes so intense that not even the fastest thing in the universe, light, can escape its pull. Yet despite their fearsome reputation, black holes are not merely destructive forces. They play a crucial role in the universe, influencing the formation of galaxies and the behavior of stars. In fact, most galaxies, including our own Milky Way, are thought to harbor supermassive black holes at their centers. Black holes that contain millions or even billions of times the mass of our sun. These supermassive black holes act as the anchors around which galaxies form and evolve, their gravitational pull shaping the very structure of the universe. So how close could a black hole be to us? Could there be one lurking in our cosmic neighborhood, waiting to pull us into its inescapable grip? The truth is, while black holes are incredibly powerful, they are also incredibly rare. The nearest known black hole to Earth is located about 1,000 light-years away, a vast distance in cosmic terms. But that doesn't mean we're completely safe. As we'll explore in this video, there are other, smaller black holes that could be much closer, hidden from view by their very nature. And with new discoveries being made all the time, the possibility that a black hole could be closer than we think is not entirely out of the question. In the next part of our journey, we'll take a closer look at how scientists detect these elusive objects. Black holes, by their very nature, are invisible. So how do we know where they are? And how close could one actually be to us? These are the questions we'll explore in the next section. But for now, let's keep our eyes on the stars and our minds open to the mysteries of the universe as we continue to explore the fascinating world of black holes. Detecting a black hole might seem impossible. After all, they don't emit light or radiation that we can easily see. But scientists have found clever ways to spot these hidden giants. One main method is by observing how black holes affect their surroundings. Even though the black holes themselves are invisible, their gravitational pull is not. This immense gravity can bend light, warp space, and change the paths of nearby stars. All of these effects can be seen and measured by astronomers. Let's talk about gravitational lensing. When a black hole passes in front of a star or galaxy, it bends the light from that object around itself. This creates a lensing effect, predicted by Einstein's theory of general relativity. Imagine seeing a star that looks like it's in one spot, but its light has been bent by a black hole. This makes it seem like the star is in a different place. This light bending helps scientists find black holes, even though they can't see them directly. Another way to find black holes is by studying X-ray emissions. When a black hole is part of a binary system, two objects bound by gravity, it can pull material from its companion star. As this material spirals into the black hole, it heats up and emits X-rays. These X-rays can be detected by space telescopes. For example, the Cygnus X-1 system was found because of its strong X-ray emissions. This led scientists to believe that only a black hole could cause this. Recently, detecting gravitational waves has opened new doors in black hole research. Gravitational waves are ripples in space-time caused by massive events, like black holes colliding. In 2015, the Laser Interferometer Gravitational Wave Observatory, LIGO, detected these waves for the first time. This discovery confirmed a key part of Einstein's theory and gave us a new way to observe black holes. When two black holes merge, they create gravitational waves that we can detect on Earth. This lets us learn more about these mysterious objects. We also track the movements of stars to find black holes. Astronomers can guess a black hole is nearby if they see a star orbiting something invisible. If the star's speed suggests it's orbiting a massive object, it's likely a black hole. This method helped confirm the supermassive black hole at our galaxy's center, Sagittarius A. By watching stars in the Milky Way center, scientists saw them orbiting an unseen object. This led to the conclusion that a black hole was there. These indirect methods have helped us map black holes across the universe. As technology improves, we may find even more, possibly closer to Earth than we thought. The search for black holes is ongoing, and each new discovery teaches us more about these strange objects and their role in the universe. Now that we know how black holes are detected, the next question is, how close could one be to Earth? Black holes are often portrayed as cosmic monsters, ready to swallow anything that gets too close. But how realistic is this fear? To answer that, we need to look at the different types of black holes and where they're located in the universe. There are three main types of black holes: stellar, supermassive, and intermediate. Stellar black holes are formed when massive stars collapse. These are the most common type, typically found scattered throughout galaxies, including our own Milky Way. Supermassive black holes, on the other hand, are found at the centers of galaxies. These giants have masses millions or even billions of times greater than our sun. Intermediate black holes are rarer and fall somewhere in between in terms of size. The nearest known black hole to Earth is a stellar black hole named V16 Monocerotis, or V16 Mon for short. It's located about 3,000 light-years away. While this might sound close on a cosmic scale, it's actually quite far. To put it in perspective, 1 light-year is about 5.88 trillion miles. So 3,000 light-years means this black hole is over 17.6 quadrillion miles away from us. At that distance, V616 Mon poses no threat to Earth. But what if there's a black hole closer than V616 Mon, one that we haven't detected yet? It's a possibility, but an unlikely one. If a black hole were close enough to affect Earth, we would likely see its effects on nearby stars or gas clouds. So far, astronomers have not found any evidence of such a nearby black hole. That said, the universe is vast and full of surprises, and our understanding of it is constantly evolving. Another interesting possibility is the existence of primordial black holes. These hypothetical black holes would have formed just after the Big Bang, much smaller than the ones formed from stars. Some theories suggest that primordial black holes could exist throughout the universe, including possibly within our solar system. However, these are still just theories, and there is no direct evidence of primordial black holes existing close to Earth. Despite the remote chance of a black hole being close enough to threaten our planet, black holes still play a crucial role in shaping the universe. Their immense gravity influences the formation of stars and galaxies. In fact, the supermassive black hole at the center of the Milky Way, Sagittarius A, is a key player in the dynamics of our galaxy. But it's safely located about 27,000 light-years away from Earth, far enough that we have nothing to fear. So should we worry about a black hole suddenly appearing in our vicinity? The answer is no. The nearest known black holes are too far away to have any impact on our planet. And while it's always possible that we could discover a new, closer black hole, the chances of it posing a threat are extremely slim. For now, black holes remain fascinating cosmic objects to study rather than dangers to fear. In the next section, we'll explore what would happen if a black hole did come close to Earth. Could we survive such an encounter, or would it be the end of life as we know it? Stay tuned as we dive deeper into the potential dangers and mysteries of black holes. So what would happen if a black hole actually came close to Earth? This scenario sounds like the plot of a science fiction movie, but let's explore the science behind it. The first thing to understand is that black holes, despite their terrifying reputation, don't actively seek out and devour planets. A black hole would have to come incredibly close to Earth, closer than the Moon in fact, before its gravitational effects would start to cause major disruptions. However, if such an event were to occur, the consequences would indeed be catastrophic. As a black hole approached, its gravity would begin to affect the orbits of planets and moons in the solar system. The closer it got, the more it would distort these orbits, potentially pulling objects out of their regular paths and causing collisions. Earth's orbit could be thrown off course, leading to extreme climate changes, tidal forces, and other devastating effects. If the black hole came even closer, Earth could be torn apart by its tidal forces. This phenomenon, known as spaghettification, occurs when the gravitational force on one side of an object is significantly stronger than on the other side, stretching and eventually ripping the object apart. For Earth, this would mean the planet being stretched into a long, thin shape before being shredded into debris. But let's say, for the sake of argument, that Earth wasn't immediately destroyed by the black hole's gravity. The intense radiation emitted by the material spiraling into the black hole would likely sterilize the planet, making it uninhabitable. Any atmosphere, water, or life on Earth would be stripped away, leaving a barren, lifeless world. In short, if a black hole came close enough to Earth to have a direct impact, the result would be total destruction. Fortunately, the likelihood of such an event is incredibly low. Black holes are rare and space is vast. The chances of a black hole wandering into our solar system are so small that it's almost negligible. Most black holes are found far away from Earth, either in distant galaxies or at the centers of galaxies where they play a critical role in galaxy formation and evolution. The closest known black hole, as mentioned earlier, is still thousands of light years away and poses no threat to us. Moreover, the universe is expanding and galaxies are moving away from each other. This expansion reduces the chance of different celestial bodies, including black holes, coming into close proximity. So while black holes are fascinating objects to study and their potential dangers make for compelling science fiction, in reality, they are not something we need to worry about on a day-to-day basis. However, this doesn't mean black holes are irrelevant to our understanding of the universe. They are key to many astrophysical processes and help us understand the extremes of gravity and space-time. By studying black holes, scientists gain insights into the early universe, the formation of galaxies, and the ultimate fate of stars. Black holes challenge our understanding of physics and push the boundaries of what we know about the cosmos. In conclusion, black holes are among the most mysterious and intriguing objects in the universe. While they are powerful and potentially dangerous, they are also rare and distant. For now, we can continue to study them from afar, learning more about the universe and our place within it. And as our knowledge grows, who knows what other secrets we'll uncover about these cosmic giants. So keep looking up, keep asking questions, and keep exploring the wonders of the universe.